Antilog approximation by hand without the use of log table, cheat lists, or the use of the Taylor series. Our antilog is based on the one of base 10. Hence, it could be written as antilog of n equals to 10 raised to the n. And for n is equal to c plus m. C stands for characteristic and m stands for mantissa. The characteristic is the integer part of and the mantissa is the decimal part. Thus 10 to the n is equal to 10 raised to the c plus m is equal to 10 to the c times 10 to the m. It is in the 10 to the m that we are evaluating with my homemade formula. And this is the formula. 10 to the m approximately equal to 2.303 divided by 1 over m plus 0.42m minus 1.146 plus 1. The value of m in this formula is limited to between 0 and about 0.4. So for m that is greater than 0.4, we have to reduce the value of m by the multiple of log of 2 or 0.30103. So m is equal to m prime, the new mantissa, plus n times 0.30103. So m prime is equal to m minus 0.30103n, where n is equal to 1 or 2 or 3. And m prime is a positive number. Therefore, we can write 10 raised to the m equals to 10 raised to the m prime times 10 raised to the 0.30103n. So 10 to the m equals to 10 to the m prime times, because this 10 raised to the 0.30103 is actually 2. This value equals to 2, so it's equal to times 2 raised to the n. So for m that is greater than 0.4, we use m prime in place of m in the homemade formula. And this is the first example. Find the log of 2.25 or 10 raised to the 2.25. So 10 raised to the 2.25 is equal to 10 raised to the 2 plus 0.25. So c is equal to 2, that's the characteristic, and 0.25 is the mantissa. Here, m is less than 0.4. So the value of 0.25 can directly now be used in the formula. 10 to the 2.25 is equal to 10 square plus 0.25 is equal to 10 to the 2 times 10 to the 0.25, that is equal to 10 to the 0.25 times 100. This 100 is from this 10 to the 2. So the thing we have to solve is for this 10 to the 0.25. Solving for 10 to the 0.25 using the formula. 10 to the 0.25 equals to 2.303 divided by 1 over 0.25 plus 0.42 times 0.25 minus 1.146, then plus 1. So 10 to the 0.25 is equal to 2.303 divided by 4. This is 1 over 0.25 plus 1.105, that is the product of this, minus 1.146 plus 1. So 10 to the 0.25 equals to 2.303 divided by 2.959 plus 1. This 1 divided by this number will get you 0.778303. So 10 to the 0.25 equals to 1.778303. So 10 to the 2.25 equals to 10 to the 0.25 times 100. So 10 to the 2.25 equals to 1.778303 times 100. So 10 to the 2.25 equals to 177.8303. And from the calculator, we find that 10 to the 2.25 is equal to 177.82794, which is the true value. So comparing these two values, it's pretty close. And the second example is the antilog of 1.78, or 10 raised to the 1.78. So here we have C is equal to 1. That characteristic, mantissa is 0.78. We know that here 0.78 is greater than 0.4. So therefore we have to reduce this 0.78 to a lower number. So what we do is m prime, the new mantissa, is equal to the old mantissa minus the multiple of the log of 2. So here we use 2. Because if you multiply 2 with the 0.3, you'll get 0.6. So 0.6, when subtracted from 0.78, you still get a positive m prime. So m prime equals to 0.78 minus 0.30103 times 2. That's the n. Is equal to this, 0.78 minus 0.60206. So m prime is equal to 0.17794. So we use this value in the formula. So 10 raised to the 0.17794 is equal to this one, 2.303 divided by 1 over 0.17794 plus 0.42 times 0.17794 minus 1.146 plus 1. So after all these calculations, you'll find out that 10 raised to the 0.17794 equals to 0.506391 plus 1. So 10 raised to the 0.17794 equals to 1.506391. So solving for the 10 raised to the 1.78 is equal to 10 to the 1, that's for the characteristic, plus the 10 to the 17794 plus the multiple of log of 2, 2 times 0.30103. So it's equal to 10 to the 1 times 10 to the 0.17794 times 10 to the 0.30103 raised to the 2. This one is, the value of this is 2. So 10 raised to the 1.78 equals to 10 times 1.506391, the calculation we made from the m prime, times 2 raised to the 2. So 10 raised to the 1.78 is equal to 60.25564. And the true value is 60.25569. So it's accurate up to the 3 digit after the decimal, 255, which is pretty close. For our third example, we'll use a negative number for our antilog. Find the antilog of negative 2.06. So 10 to the negative 2.6 is actually equal to 10 raised to the negative 2 minus 0.06. Because these two, when you add them together, it's equal to negative 2.06. So what we do is, in order to make this mantissa positive, to be able to substitute to the formula, we add 1 to the characteristic and add 1 minus to the characteristic and 1 positive 1 to the mantissa. So this thing will equals to 10 raised to the negative 3. You add 1 negative 1 to negative 2, become negative 3. So you add positive 1 to the negative 0.06 and you'll get a 0.94. So therefore, 10 to the negative 2.06 is actually equal to 10 to the negative 3 plus 0.94. So we know that 10 to the negative 3 is just 1 over 1,000. So now our problem is to solve for 10 to the 0.94. So we know that 0.94 is greater than 0.2. So we have to reduce this 0.94 to something less than 0.4. So we use n is equal to 3. Because this is 0.94, so the third multiple of 0.30103 is 0.90309. That is when n is equal to 3. So m prime equals to 0.94 minus 0.30103 times 3. And that is 0.90309. So this one minus that one, you'll get the new m prime, which is 0.03691. Use m prime as with this value 0.03691 in the formula. So substituting 10 raised to the 0.03691 equals to this, 2.303 divided by 1 over 0.03691 plus 0.42 times 0.03691 minus 1.146 plus 1. So if you just follow this calculation, you'll end up with 10 raised to the 0.03691 equals to 0.088752 plus 1. So therefore, 10 raised to the 0.03691 equals to 1.088752. So for 10 to the negative 2.06, then that is equals to 10 to the negative 3 plus 0.94, which become this one, become 10 raised to the negative 3 plus 0.03691 plus this log of 2 value 0.30103 times 3. That's the n is equal to 3 multiple. So 10 raised to the negative 2.06 equals to, that's 10 raised to the negative 3 is 1 over 1,000 times 10 to the 0.03691, that is the m prime. That is, we solve it as 1.088752. And this one, 10 raised to the 0.30103 is actually 2. That's the value of it. But it is raised to the 3. So it's equal to multiply by 2 raised to the 3, which is 8. So therefore, this is the value now. Equals to 1 over 1,000 times 1.088752 times 8. So calculating, divide by 1,000, we found that 10 raised to the negative 2.06 is equal to 0.0087096,416. And the true value is 0.0087096,359. So it's accurate up to here. It is really very close. Our fourth example is the antilog of 1. So we try to find what is the antilog of 1. We know it's 10, but we just use the formula to find its value. So 10 raised to the 1 is actually equal to 10 raised to the 0 plus 1. So the characteristic is 0 and the m is 1. So since m which is 1 is greater than 0.4, so we have to reduce this again by a multiple of 0.30103. So we know we have to use 3 because it's 0.9, which is slightly less than 1. So the m prime now is equal to 1 minus 0.30103 times 3. It's equal to 1 minus 0.90309, and we get a m prime equals to 0.09691. So plugging in this 0.09691 into the equation, 2.303 divided by 1 over 0.09691 plus 0.42 times 0.09691 minus 1.146 plus 1. So calculating that, we found that 10 to the 0.09691 equal to 2.303 divided by 9.2135 plus 1. And here we see that 10 to the 0.09691 equals to 0.24996 plus 1. So 10 raised to the 0.09691 equals to 1.24996. So going back to the 10 to the 1, 10 to the 1 equals to 10 to the m prime times 10 to the 0.30103 times 3. So that is equal to this, 10 to the 0.09691 times 10 to the 0.30103 times 3. With 10 to this is equal to 2. So it's equal to 2 raised to the third power, which is 8. So 10 to the 1 is equal to 1.24996 times 8. So you get 10 to the 1 is approximately equal to 9.99968. And of course the true value is 10. So this one compared to that one is also pretty close. So in summary, the antilog of a number n is actually equal to 10 raised to the n, in which n is equal to c plus m, the characteristic plus the mantissa. And if n is a negative number, negative n is equal to minus c minus m. So minus 1 from minus c, and then add 1 to the minus m mantissa. So therefore, minus n is equal to minus c minus 1 plus 1 minus m. Plus 1 and minus 1, so it cancels out. So these are the new characteristic and mantissa if you have a negative number. So mantissa m has to be less than 0.4 to be used in this formula. If mantissa is more than 0.4, reduce this value by the multiple of log of 2, i.e. n could be equal to 1 or 2 or 3 depending on the value of the mantissa. So m prime is equal to m minus 0.30103 n, such that the new m prime will be between 0 and less than 0.4. So therefore, 10 to the m will now equal to 10 to the m prime times 2 to the n. That's a multiple. So that if m will now, if it's between 0 and 0.4, then we don't need the n. So n is 0. So 10 to the m is equal to 10 to the m prime times 2 to the n in general. So 10 to the n is equal to 10 to the c plus m is equal to 10 to the c plus m prime plus 2 to the n. So if it's negative, if n is negative, 10 to the negative n is equal to 10 raised to the negative c negative m is equal to 10 raised to the negative c minus 1 plus 1 minus m. Thank you.